And today, we strongly feel that with the industry experts in the panel, and there are a lot of key takeaways for our members. And thanks to all for joining online. And I also specially acknowledge Madam Maya Haruki-san from Osaka City Economic Strategy Bureau. Thank you very much, ma'am, for your kind participation and support to the Chamber in its initiatives. Um, I would like to briefly introduce the panelist for today. We have Mr. Prakash, who is the chairman of our manufacturing expert committee, and he brings over 30 years of experience across the machine tool and automotive sectors, covering various subjects like production, assembly, maintenance, quality, you name it in the manufacturing sector, and he is there and value streaming mapping. He also has a strong technical expertise in metal cutting, grinding, welding, additive manufacturing, and IIoT. He is a certified member in theory of constraint and is also a member of TOCICO. He also is the certified trainer in Toyota business practices and an active member of the Quality Circle Forum of India and Indian Society for Quality. Welcome to the session, sir.
Thank you.
I now would like to introduce Dr. Devarajan, who is the past president of the Chamber and senior vice president of TVS Motor Company. He has been associated with the TVS Motor Company for the past 38 years and has led new product development for the company. In his current role, he is facilitating the implementation of new process technology, lean manufacturing system, and digital manufacturing. He has been awarded the prestigious Rolls-Royce Award for Excellence in Manufacturing Concepts and Implementation in UK, and the Thought Leadership Award by Automotive Manufacturing Solutions UK. Welcome for the panel, sir.
Thank you. Thank you.
And now introduce Mr. Karthikeyan, who is the co-chair of our manufacturing expert committee and chief technology officer of EDS Technologies Private Limited. And he has over 35 years of experience in manufacturing technology with early domain expertise gained at Ashok Leyland and BPL Limited. He has enabled digital transformation for hundreds of organizations across product development, engineering, manufacturing, supply chain, and enterprise collaboration. He actively contributes to industry panels and academia, guiding policy adoption and workforce skilling for the digital future. Thank you very much for being on the panel. And now I'd like to introduce Mr. Rabindra Saha, who is the moderator for this panel discussion. And he is also the chief of our BCIC editorial board, and he's the chief technical officer at Indian Register of Shipping. He has over 30 years of experience in engineering services, digital technologies, Industry 4.0 solutions, and he previously has held senior leadership roles at Tata Technologies and Tata Motors, leading strategic technology initiatives. He is recognized for his ability to lead complex digital transformation programs in large organizations, and he continues to contribute thought leadership towards shaping the future of maritime technology and operational excellence. Thank you very much, sir, and welcome to the panel discussion. I also would like to acknowledge the support of NTTF and Indo-MIM for live streaming this session amongst their associates. Thank you very much for your support. And finally, I would like to thank all our annual sponsors for their immense support for the activities of the Chamber throughout the year. Now I request Mr. Rabindra Saha to take it over from here. Over to you, sir.
Thank you so much, Rupa ma'am. So wonderful to start the morning with a nice introduction and setting the context for this this webinar. And good morning to all of the participants. And we have got a stalwart from the industry, the domain expert in manufacturing excellent experts and technology all come together to talk about very important topic, which is quality. So is a very nice webinar is planned. Manufacturing quality, elevating standards for next gen quality practices is very, very important to know, learn, and we are going to have a very wonderful interaction with the question. So for all the participant audience, I request during the session, you can post here any questions on the chat box. As and require, I'll take up those questions with the panelists, and would like to hear from the panelists. Panelists, thank you so much. I will start with first Mr. Prakash. So we have been so stalwart in industry, in manufacturing, and the quality. And so I'll ask questions focusing to you on quality excellence through process discipline, process precision manufacturing, and internal customer concept. So my first question to you, in high precision capital machinery like CNC turning centers, what is the biggest barrier to achieving consistent world-class quality? Mr. Prakash.
Yeah, thank you, Mr. Ravinasa. First of all, I would like to welcome all the participants for this session. And this month being celebrated as a quality month, I think in India and throughout the world, just to promote the quality awareness and also not just on the products and services, but also I think it's a broader purpose is to actually enhance the quality of life. So I think I'll just start with a few of these things. And I think in India, the CQI has actually given us the this month theme as Think Differently. You know, that's the theme of the quality month for India. Now, I represent aegis Designers, and also aegis Designer is the largest CNC manufacturers of machine tools in India, having about 30-35% of market share in India and also about 5% exports. Now, with this, I think one of the interesting questions which Mr. Rabindra Sa has asked me is about barrier for consistent quality in machine tools. Now, I would like to draw the attention of the audiences is that while of course machine tool needs to be manufactured, it needs to be built. But there is a slightly different environment in which the machine tool works. Now, I would call that from a broader perspective as a machine tool is a discrete manufacturing. I just wanted to draw some parallel, or I would make everybody to understand, make it easy. Is when I look at automobile manufacturing, auto manufacturing is a more of a mass production manufacturing. Now, somebody may even challenge me and say that, no, even automobile has a lot of varieties. When I say mass production, I would say that the demand and the supply side, the stability is far better when it comes to automobile manufacturing to machine tool comparison to machine tool. So this is one aspect. Now, when you look at the entire manufacturing process itself between an auto as well as a machine tool, I would like to keep the reason why I generally, because most of the people are very well aware of the automobile manufacturing, and it's been a very established base in India also, and India being the largest, I mean, even the fourth or the fifth largest manufacturer of automobile in the world. So almost there is always a large comparison to the automobile, but just to give a perspective about what it means, in terms of manufacturing quality, why manufacturing quality is quite challenging in machine tool is that about the process stability and the process consistency is completely different because the nature of manufacturing is different. So in a discrete manufacturing, what happens is there's always a change. The batch quantities are so low. You can call it as a job shop, but not exactly job shop for the scale with which aegis Designers is actually working. But still, I would call it as in terms of compared to the auto component, this is like a 1/10 of that manufacturing in terms of production quantity. Now, one of the barriers definitely are related to the process discipline, what is there in machine tools, and the component variations and the assembly practices So machine tool is generally considered as a project driven process, which means every machine needs to be scheduled like a project when you want to build the machine. We are one of the pioneers in machine tools to set up a flow line similar to an automobile line. We have set up in our plant. But in spite of that, I would say that the process variations are quite high. And that is one of the challenges, component variations. And the building quality into the process is one of the challenge because of this. Second important thing, the customer requirements are completely made to order. That means machines are built while the platform may be same, machines are built what actually customer wants, and each customer has a different specifications requirements. It's like a make to order or an engineer to order environment. So this gives kind of a higher level challenges in the production, the manufacturing processes, and the assembly practices. So I think these are few of the challenges and the barriers for achieving a consistent quality, I would say, in a machine tool. Coupled with this, I would like to also mention that the machine tool itself of course, it is called as a mother of all industries. And every machine or a part which comes out from any industry needs a machine tool. So the mother industry or mother machines which are required to produce these machines, also the technology barriers are there, and that also actually limits the quality of the products what machine tools produces. So these are some of the things which, and India still does not have the capability to build mother machines. I think this is the reason why we still have to rely on certain the well-known machine tool manufacturers like Maurice Seiki or a DMG or from a German, it's called Heller. These are some of the things which they have established much ahead and much more accurate. And there are a lot of things to learn from there to actually maybe become more on the we can build our own mother machines. So that's my viewpoint. Over to you, Saha, on this issue. I think.
Yeah. Can you hear me?
Yeah.
So thank you so much. You rightly mentioned about nowadays there's a make to order. And process discipline is very important to achieve the quality. So I'll come back to you and I maintain the same challenges I'm taking to Devarajan sir, Dr. Devarajan sir. Sir, when we talk about zero defect systems, when we talk about the systems where the systems is important, culture is important, and supplier capability all are equally important, right? So as we know, TVS Motor is known for consistently high quality. So my question, what drives this consistency, sir?
Yeah. Thank you very much, Rabindra. I think Prakash did mention about discrete manufacturing. What's happening, I think, when you're talking about think differently in quality, that's applied even for automobile industry. Okay, we might think that automobile industry is a continuous production. We have both mass production as well as batch production as well as single product production also. Because today, as India is becoming younger and younger, each customer is different now. Each customer is new. So it's almost like building each vehicle for each person. If I see our assembly line, we have number of models simultaneously running in the same line. And for example, in BMW, we make vehicles based on order only. Only when the order is released, each one will be different. So it's a combination of both things. So according to me, what is thinking differently? See, quality actually what means, it means conformation to specification. Okay, it says that it has to be produced to producing to what defect-free areas to meet customer expectation. Now it is changing towards, okay, focusing towards reliability, durability, performance. Today, it is not only defect-free production. It is about creating a value, creating a differentiated product through innovation, sustainability, and digital. So that is a change which is happening today because India is a younger world. It is redefining the quality by embedding the customer expectations. That is a new thing which is happening now. Quality is no longer a checkpoint. Okay, it's very, very important that it is a mindset. So if you go by the zero defect manufacturing is a philosophy. Okay, it's a systems approach aimed at eliminating many of the errors of production process. It's a mindset than detecting the later. It emphasizes doing right things at the right time, integrating technology, process optimization, and more important, according to what Prakash did also mentions, human discipline. So if you talk about Industry 4.0, which is driving every industry today, there are 3 or 4 points which is differently today in any industry. One, many of the areas, digital twin is coming to picture. Try to go at the origin itself, design to manufacture, design to assembly, design to maintenance, design to ensure that the customer gets the benefit of it, designs for durability. Can it be built in terms of digital twin, modified, changes, so that we'll be able to get the product earlier? We always call it quality, cost, delivery, QCD. In India today, it's changing to QCT, quality, cost, time. Time is becoming an essence when the GDP is growing. Okay, India is the fastest growing. We are number 3, number 2 in many of the automobile industry. Many of the industry today, many of the customer today are Indians only, or the India itself and to the world. So digital twin is the first thing which is coming. The second thing is coming into putting into sensors in many areas. IoT-based sensors. Get the data captured. Get the machines captured. Why are we trying to do this? To be competitive. Automobile industry is highly competitive. Okay, you can't know how difficult the industry is. Hence, we need to eliminate the waste. How to eliminate the waste? Get the data from the machines itself. How to improve the productivity of the machine. So IoT-based sensors for real-time monitoring and machine performance. Based on this, automation and robotics, affordable automation. In fact, India, we have got majority are MSMEs. So how we can have affordable automation to MSMEs? MSMEs contribute something like 90 or 80% of the job today. 50% of our corporates are coming from the MSMEs itself. And they contribute something like 40 to 50% of GDP itself. If manufacturing contributes to 12 to 13% of GDP, it's going to go up to, say, 20%. MSMEs have to pick up on the same area. Doubling up the MSMEs. If you say today MSMEs are stronger, imagine a situation in 2030, doubling up of all MSMEs, doubling up of volume in a case to meet the $5 trillion or $10 billion economy. So that's a change. So automation and robotics come into picture, skill sets, and AI and predictive analysis. And the most important thing is on the skill sets. Okay, SDCA, PDCA, skill sets improvement. How to build this culture? How to get into the zero defect culture? It extends beyond machines. It's about people. It's about values. It's about attributes. So we go into 4 or 5, again, key elements. One is commitment from the top, whether it's MSMEs or the machine or whatever factory, how to have commitment from the leadership team. Continuous communication about the goals, purpose in which we are there. That's a change. Second thing is empowerment. Employee empowerment. Ensure that the operators are identify and solve problems at their stage. Second. Third is, I think, if I really put it into a different way, continuous improvement. Kaizen, SDCA, sustain and do well, systematize and do well, change management, unless it is affordable. See that it is continuous improvement, small, steady improvements. Fourth, very, very important thing is cross-functional collaboration. So whatever we have, digital, whatever we have, it should be cross-functional, seamless energy between design, production, supply chain. For example, if you take Toyota, for example, they have zero defect culture through Jidoka, Kaizen principle. Even Motors, we're talking about the total quality management in terms of the process quality circle. We have QCC, SIT, supervisor improvement teams, breakthrough management, many other areas. It has to be built at every stage. Build the strong employee involvement strongly through all the QCCs. Next level on the supervisors level. Next level is on the cross-functional teams. And through the top management is through the breakthrough management. So it is the cutting across all the levels. So that is a change, that is an improvement is happening today. That gives you customer satisfaction, customer experience. So we have to build this by empowerment, involvement of all the members. That's the type which are trying to do it in TVS Motor. With just a starting point, I think it's most important is to get people together and see that the purpose in mind to deliver. So that is, I'll come back to you later. I think this is my initial thoughts of it. Yeah.
Sir, thank you so much. So nice, valuable points. So a couple of points I just noted. It's all about mindset, and quality is no longer we can compromise. Empower operators, and then creating a value differentiated products. So these are the good point came.
Another
moving
point which
from
is
QC.
coming up, I think many of the Indian situations, Ramendra, what's happening is we're talking about the cost effectiveness. Okay, we talk, okay, India is cost effective, but it is shifting towards value creation.
Yes.
Shifting.
Yes, yes.
So the purpose in the mind of people working will change in a broader picture and ensure it is, for example, a broader picture of sustainability, digitalization in a broader picture. That is for the benefit of the company itself. It is a mindset. Okay, use of digital tools are okay. Value creation, customer trust, manual process into smart data. So I think we are broadening up the people's viewpoint to deliver the India's growth. That's the way I look at quality differently.
Yes, sir. Thank you so much, sir. You're very right. Each customer is different, and conformation to the specific is the key. And you spoke about, sir, elimination of the waste. We spoke about skill set, people, culture, Kaizen, CFT, and digital twin is equally important, right? So from this, no one can be better than Mr. Karthikeyan, who is over 3 decades of experience in technology across India, outside India. Let me ask you questions to you related to technology, how it is helping. So, Mr. Karthik, my questions to you is where will digital transformation have the biggest impact in quality in next 5 years?
Thank you, Ravindra. Thank you for being part of this panel. I'm glad that I'm sharing the thoughts with all eminent leaders, Prakash San and Devarajan San and you. The thoughts that reverberate what Prakash introduced, build to print and mass production. So that was one of the transformational thinking that's happening. When technology is in race with demand, especially the transformation of anything is possible only when there is a gap between what industry needs and where the technology is lagging. In some cases, technology is leapfrogging because there are a lot of innovation in technology, but not embraced in industry. So it's a kind of a situation where which leads and which lags. But manufacturing has been in the world for long years. So the technology is just a kind of a cosmetic thing that is coming in, and it is getting revolutionized. But as Devarajan talked about, the Toyota could be an example, or TVS can be an example, or many people. So the technology is constantly pushing the industry to see how this enables to realize the dream in terms of value, as Devarajan summarized very nicely. When there is no value to the product or no value to the customer, no one is going to look at any technology. When we buy anything, we look at the utility value or what you call implementable value or realizable value. If the value is not inbuilt, either in product or in process or in service, it is just no use to anybody. So the transformation is a good word. It's very abused word in the industry, because I would say everything, if you don't say transformation, then means you are static, you are ignored in the market. You have to say in the world that you are transforming. The transformation is either as a leadership transformation or an employee transformation or a business transformation. The word is imbibed in everybody's ethos books, saying that, are you transforming? Just to connect to the quality, digital transformation will have a biggest impact on quality in manufacturing over the next years. How it is enabling? It's an highly automated. I think Devarajan talked about it in a very nice perspective. It should be data driven. It should not be like emotional. I'm good. I'm a good inspector, quality inspector, I%. It should be data supported. It should have a predictive nature, because Today, people are talking about it should not be reactive. The event should be predicted so that outcomes can be better managed. So the predictability is an important paradigm where the transformational technologies are pushing. It's all leading to what you detect the defect, and process can you optimize, and compliance can you meet. So these are all the three paradigms which it definitely drives, and the technologies are leading the scope in that way. One of the factor, if I don't talk AI, I'm not right to be in this forum, or nobody will listen to me if I don't use a word in my conversation. It is more abused word and more relevant and more connected to this world. So if I don't have an AI-powered automated inspection system, as Prakash San said and Devarajan sir said, the adoption level, the maturity level of AI between MSME, SME, established industry, and classified industries are different. But this is being kind of visioned in the system by the quality leaders of the company. Is it a CEO's mission? Answer is no. So, but the digital transformations are sold to CEO, but the quality is embraced by the person who is in the shop floor. This is where the cosmetic value, the kind of a stitching value need to be sold to the CEO. Why the quality needs to come more than manufacturing itself. Can I produce these words which can give a customer a confidence? So are you imbibing AI-led initiative could be the one of the game changer that will come for predictive, if not for anything based on the past data, it can give you a predictability. Computer vision, I think Devarajan sir said very nicely, camera which is used earlier to only do some kind of vision analysis or something. Now it is imbibed in process industry to the discrete industry, how it can be a kind of storyteller about the complete process, what's happening, a kind of a lens, what we call the lens of the factory. So it's going to become more and more relevant. I think it is gaining grounds. Computer vision based inspection can be embraced by MSME also. It need not be the only by the very lead in emerged industry. It really drives a kind of a simple technology, but it is very augmenting the business. IoT, yes, to small level, everybody says I'm smart product. I have smart sensors. The smart word, AI word, I'm trying to bring in. I think every MSME can get that idea. It could be of more use, even if it is edge computing, to a sensor that can give a kind of a continuous data for them to make some informed decision and to connect to the quality management system. If it is a simple homegrown system to an established ERP level or any other sophisticated system, it can help. What does it help is root cause analysis, predictive maintenance, informed decision. This is an outcome from these initiatives. Transparency and compliance. These two are the one which will come in both from the manufacturer and supply chain and the overall documentation and robust regulatory compliance. In order to do the traceability, the blockchain, what you talk about, the traceability of the part when it is produced, it is like going back to the Veda, where was my grandfather, my great-grandfather, my history is traced, or my DNA is being traced. Like this, every product has a DNA. How do you trace this DNA through the system is also possible by blockchain. These are all the words I would say. I just have only 1 minute. How does this new KPIs coming into business? Because every quality industry has a KPI. The next gen KPIs are predictive defect prevention compared to the defect rate. Earlier it is defect rate, now it is moving. Time to detect compared to the inspection cycle time. That means there is a transformation from the traditional KPI to the new KPI. Automated AI-based inspection coverage compared to the quality audits. Quality audits are done post the fact. Another one is percentage automated defect correction compared to the manual rework rule. That means how much I do manual, I rework it. Quality of customer experience, net promoter score is one of the things which every company is now promoting as compared to customer compliance I manage, which is the traditional KPI. Data quality and integration index compared to the incidents report. So in that way, it is going to be the huge transformation. In order to support the next gen KPI, you need a digital transformation. Thank you, Rabindra, for your listening. And
Thank you, Karthik. And in a very short time, we have given a very nice capsule of everything, every aspects from technology and domain side. Thank you so much, Karthik. And you rightly said the technology is to solve problem, to create value in product, process, and services. Very well said. Now, you spoke about MSc. I see a question. I'll ask quickly to you before I go to Prakash San. You spoke about MSME. So many MSMEs believe digital quality tools are expensive. Is this true, Artika?
It is. It depends on who needs more. One of the thing I'll tell you, if my industry as an aspirational industry, and I know I am moving away from a traditional view to a very forward-looking view, no technology is costly. I'm just putting it, I'm not saying as a statement word. But if I aspire to become a supplier to Volvo, I'm just putting in a global scenario, or I'm supposed to go global rather than being confined to only the ecosystem, what is visible to me. So I'm not going to be the frog in the well. I want to be the roam the world. That time you definitely need, the cost is a myth and it is a factorization in mind. That's what I would say. But today, the subscription-based technologies have come. Cloud-based technologies have come. It helps many industries to look at it. And then I'm not biased about what I promote or what you promote or anybody's in the market. There are a lot of due diligence available to know and to embrace, because today customers buy based on references, based on past experiences. I wish many of the technology, what I am talking about, MSME should at least consider and try and learn. Their failure can be a stepping stone to success. At least there's a new beginning. If you don't make any beginning, then there is no learning. So I would say that the cloud-based technologies with a low cost, and there are a lot of low-cost manufacturers in digital transformation available. With we are also initiating with IIIT, and then we did a small startup award for a lot of people, entrepreneurs who are willing to take this kind of industry as a learning curve. If there are anybody interested in this audience, they should definitely embrace, and they are ready to build a prototype, especially for their specific business use, if they do not want to embrace a big bang, big father solutions. So there is a way, but the need to be more compelling than the technology.
Yes, Karthik, you rightly said that any day is the beginning. We need to start. Awareness is important. And what we see, the technology on the cloud-based, subscription-based is the pay and use as you need it. So that's where the cost substantial can be cut. Now I'm coming to Prakash, sir. Sir, whenever I see you, there's so much of stalwart your work done in the manufacturing. It reminds, when I see you, it reminds me that the Tata Motors days where I cut the first generator CNC program, I cut a physical wood from the machine and generate for the country. I remember that was 1993. So when I look at it, kind of experience you are carrying. So I have questions for you. You know, sir, when you look at the Indian OEMs, face rising competition from global players. As you know, the Japanese is there, Korean is there, right? What should Indian manufacturers change immediately to act? Prakash, sir.
No, I was very much, just listening to both Dr. Devarajan as well as Mr. Karthikeyan on those aspects, which really, give me some inputs on there are certain gaps which exist in machine tools. Now, as I just said, while those are some of the very high level activities, in machine tools, the most important thing is I would just say that we have to look at three important words. That is move, tighten, and improve. Now, when we say move, I would say basically machine tool still is working with a certain tolerances, tolerances. Now, I think in automobile and all, it's very clear. There is a tolerance band, there is a control band. But being in the machine tools, still people work with the tolerance band. That is what is given in the drawing. Because it could be because of various nature of industry or a type of production. So first thing is, in order to compete with the global players, we need to move away from meeting the specification to beating the specifications, which means we need to adopt this concept, which is very well practiced in automobile, to bringing it to a 60% or a 70% limits of the tolerance. And that is, it's not that difficult, but of course challenging. Second one is a machine tool generally is built with the various very micron level accuracy setting, both in a static and a dynamic areas. Those areas also, machine tools, when you build component over one over the other, sometimes the accuracies actually get nullified or it get magnified. These are the two things which will happen in, and depending on the best fit, the output of the machine, the final accuracy of the machine also matters. So even in those areas also, not just at a component level, at an assembly level also, the machine tool manufacturers have to start now, limiting the total tolerances of the ISO standards to global standards, like meeting within a 50% of the accuracy levels when the machine is built. And while of course this machine is only a build, finally the customer, what they look for is what is on the product what they manufacture. So in order to achieve that, even the machine tool manufacturers have to also improve on the test piece quality they actually produce and confirm that entire component level accuracy as well as the machine level accuracies is actually meeting the real desired level or expected quality requirements of the customer or the end user. And I think these are the three things I would say that if it is followed up in the OEM like a machine tool, then we can actually compete with the global players. I'm very sure that we have that capability. Probably we have been so far satisfied with, okay, it's allowed to be okay because it's just meeting the requirement. Now with the lot of global players setting up their shops in India, it's high time that the Indian manufacturers actually tighten this and meet or even go above the expectations of the competing players and achieve that kind of a thing. And I'm very sure in India we have that capability, and we can do it with a very good exposure and experience from automobile manufacturer and learning. It is possible to set this kind of a benchmark and still compete with the global players. Now, there are two aspects I think I wanted to just mention. India is a highly price sensitive market. And having said that, my own experience, it's not that the people are not ready to pay more. I think this also holds good with our Mr. Karthikeyan mentioning about, or you are asking a right question, whether digital technology is costly or not. So unless a customer finds a value, he's ready to pay more. I think I can give you one example of our daily life itself. Gillette razor blade, a shaving blade, costs 300 rupees. And there are people to buy. Now, you may always argue that the standard of living has gone up, the earning per person has gone up, average per capita has gone up. But still, as long as you are meeting the need of the customer, and customers definitely every customer has a pain point. And as long as you understand those pain points and exceed or give a suitable solution, customer ready to pay. It holds good for us in OEMs also. So I think the expectations are changing. We need to actually level up to that expectations by enhancing the process quality, the product quality, and the final machine quality as well, which will actually enhance his product quality. I mean, when I say OEMs manufacture the equipment or a machine tool, it has to actually give a better value. Now, if you see the way it is changing is more of EV vehicles are coming into picture. The noise target levels are becoming stringent. The component level accuracies are changing from all usually accepted, like earlier used to be 10 microns, used to be normal thing. Okay, it's a very high quality. Now it's called as even 2 microns, 3 microns level accuracies are being demanded. So which means the machine tools also need to change and also need to tighten all these things. It is not possible only by the component. It, of course, we need to build in the technology. I'll give you a simple example of a machine tool where the normal castings, the nature of the castings is to absorb the vibrations. Now, to enhance this, people actually called as a mineral castings. So this is some of the things which we need to quickly adopt and actually enhance the quality of the machines. So very simple, it's very complicated for a common man to understand that how an accuracy is achieved on a component of an automobile part by a machine. So these are some of the things I would say that if we adopt these things along with, I think Dr. Devarajan rightly mentioned the skills, the value, the people, adopting the digital technologies, all this have to actually, collaborate with each other to achieve this kind of competing levels of manufacturing. I think that's from my people. Thank you.
Thank you so much, Prakash, sir. You rightly said, if you create the value, customer is ready to pay, right? And very nice insight you spoke about on tolerance and accuracy for the Indian OEM. Thank you so much, Prakash, sir. So now we have spoken a lot about the culture, the mindset, and supplier is equally important in our entire ecosystem. So I'm coming to Devarajan, sir. So how do you drive zero defects thinking across supplier, which is a partner, thousands of suppliers, and shop floor associates? Sir, you.
Excellent, excellent. It's a very important question, Rabindra. I think you touched the very important because everyone today feel that Toyota can do or Volvo can do all this automation and IoT and things like that. But actually, the main stream for Indian industry is the MSMEs coming to picture. Okay, major. I think around I was again mentioning earlier, around 80 to 90% of the workforce are in the MSMEs. And our customers, for example, OEMs like us, the most important is our customer base from the supplier end and on the end customer. Both are important for us. And of course, on the education from the people coming into our factory. So that is an important thing. So according to me, in terms of the supplier capability improvement, there are three pillars which is most important for us. One is how we can be transparent both sides, both from the like what Prakash was mentioning about tolerances and how the machine component is getting manufactured. Transparency among both sides. So hence digitalization will help in the picture. Get the data from the machine instead of the person giving the data to you. So bring the digitalization in a simpler way, put sensors in many of the older machines, existing machines or the new machines. See that the data is captured from the origin of manufacturing. So that's the first thing. I think data transparency would drive this. Second thing, definitely capability building and audits. Audit meaning diagnosis. Work together, sharing some of what you have done inside the factory to the supplier. Ensure it is diagnosed and improved, not auditing. Auditing is finding out fault. Can we diagnose to improve ourselves to improve again? Because today we can't say all suppliers. Believe me, many of the good suppliers in India have got very good technology. So we need to tap the technology for the benefit of OEMs. There's nothing like OEM being higher and supplier being lower, nothing like that sort. Because many of the suppliers have got excellent technologies which are trying to do. How we can capture co-building with the supplier, collaborative platforms with the supplier, working with the supplier, OEMs and supplier to co-develop many of this development. That's the way of bringing the involvement of supplier. That is the second thing which is important. Third is definitely on education and training and on the fundamentals and statistical tools. Very, very important, the statistical tools take decision areas in which you are talking about. So how to bring this working together with the supplier. So, and of course, supplier implement development plans, programs for the SMEs, working with the suppliers with all the skill sets training, cluster-based approach, including for the R&D development on technology and testing and support. So like this, see what's happening in India today is push and pull from the government. Push from the government in terms of you already signed COP, sustainability will come into picture. In fact, believe me, when we were in 4-5 years back, India was BS3 in emission norms. Today, with the force from the government, we are BS6. Many of the EFIs come into picture, all are digital coming into picture. That is for the push from the government. And of course, we should become zero emission in terms of in the next few years in now. So this is becoming very important. Second is pull from the customer. We have got the maximum export opportunity. India is the manufacturing base. Everyone is coming to India today. All top manufacturers are in India today because there's a huge market in India and a huge export. So that's how they push and they pull. If you do the drivers for it, product drivers on improvement, process drivers on improvement, sustainability is an improvement plan which you're talking about, and definitely the skill sets. So in all these 4 fronts, integrating with the supplier, integrating with the customer in terms of the requirements, that will help in improvement of the supplier capability. Another thing which is important, it all starts from the team or the member themselves. So if you really say main thing would be 3 E's again, which are the enthusiasm in what we tend to do. Is an industry. India is growing. As an MSME, we should not think we are MSMEs. We are a part of the growth of India. Each metal cut, each bit of software-driven area which you're doing, each amount of assembly you're doing, think in terms of the GDP growth of the India. So look at the enthusiasm which you have. Second is encouragement among ourselves. Many of the areas. And 3, definitely it should be extended implementation. Whatever you're doing here can be extended implementation. So another thing which is, if you drive this differently, like what we started with quality differently, it starts with all of us in this program. That's what we believe in BCIC. We believe in ourselves. First, we should have energy in ourselves to do it. We should believe that India is growing. We are in the growth plan. Difficulties are there, but we have to overcome as an opportunity. We should take that. First is the energy among ourselves. Second is to build energy among a team. Our own team, supplier team, involvement of people, whether it's a syllabus in our university or working on the digital, energize the team. Third is to have empathy in listening to people, because we've got so many new ideas of suppliers. Are we listening to them? So many new ideas of an engineer coming to a company. Are we listening to them? Should have definitely empathy. Fourth is an edge in terms of technology. Do we improve our technology ourselves? Because digital tools are increasing now. IoT is coming, ChatGPT is coming to picture. Are we as a manager or the leader of the company taking to the next level of edging the technology, learning of the thing? Fifth is to embrace this new technology. Not debating, saying that, oh, we have done 40 years, 30 years is fine. Nothing, it's changing every day. Okay, that is, and sixth is in terms of the environment, what you want to implement. I think if you bring into an overall picture the growth mindset and towards the improvement of the entire team, the entire thing will change. That's the thing which is happening in India today. It's happening in all the industries. Believe me, if you go to aerospace industries, small industry in Jalahalli is doing components for aerospace. And if you really go and talk to them, they say, this is my component which is made for the aerospace, which is going to the satellite. So the amount of change happening in India is there. The students coming in today from the colleges, they know all about the latest tools. Are we trying to adopt them, help them to implement in our factory? Again, drives comes back to us. So that's the area in which we're not talking about supplier. It's an extended enterprise. We're not talking about the engineer. He's also an extended person coming into a factory. So like that, we have to broaden up. That is thinking differently according to what we can do for our industry. So main thing is different programs, traceability system, cluster-based approach, working as an education and training, transparency in what we are trying to do, and making as a coherent focus towards the bigger picture of the growth of India. So that's the area in which is happening. And with that, there's a huge potential of our outside export market. So we are not, MSME should not think I'm making only component for example, TVS Motor or Toyota. That product is going all over the world. So they are making the component for all over the world. Hence, we need to ensure that the quality is taken into picture. You should have data on what you have done. There's a threat also other way. So if you really see today RTI, people can, if you are exporting to different countries, if a small problem occurs, there's a huge changes happening from the pressure from the customer himself. So we can't take any chances. So there's a threat from that angle. So there's an opportunity, there is a threat. So this is the right time in which we need to adopt, extend to the different way of thinking quality, at the same time, strengthen our basics. We should ensure that we know very well what machining we are doing. We know very well what tooling we are doing. We know what are the issues coming in terms of the basic level of material handling, basic level of methods, and work towards the improvement. That's the way in which we are trying to work along with our own team as well as suppliers.
Thank you so much, sir. Always listening to you is always inspiring. A lot of things we learned, right? You spoke about 6C. C is really motivating and it's a lot of things to learn. Three important things you spoke about, sir: education, training is skill. And then you talk about capability building. That's basically diagnostic, learning from the use cases. And the last point which you spoke about in the initially, data transfer, digitization of the data. So I'll just connect with you. I see questions in the chat box, sir. So this is a question on MSME. Can you little bit elaborate for MSME data transfer, data digitalization? What approach? A little bit more detail on that, sir. Devarajan, sir, to you.
For me? Okay.
Yeah.
See, what happens is, I'm talking about transparency in both the ways. See, what are we talking about? The amount of specification of the drawing which has been given and how it is made in the manufacturing front. So if you really say, for example, welding, for example, if you're saying welding or in terms of manufacturing, in terms of machining itself, are we getting the right edge preparation for the welding portion? How well it, because the process is very, very important. The process depends upon the child parts, the gap between the two components before welding. It's not filling the weld. It's not that they're not the welding. Welding is a process. But how is the component level availability for the welding? Similarly, for machining areas, what are the parameters used for machining? Can we capture this data from the machine itself? Can we capture the data from the welding torch itself, whether the current is okay or not? Because the output depends upon the input. So if you can focus very simply, in a very, very simple way, go into the elements of work, elements of your machine, elements of your component, that is quality. Instead of saying, no, I've got digital tool, I've got the simulation. Apart from that, if you are ensuring that you're building the processes at every level, at every step, that becomes a thing. So if you extend the same thing forward, if you apply the 5M conditions in properly, in your own area, it's simple, it's not rocket science. Are we ensuring that the machines are okay in our area? Whether the TPM conditions in the machine itself, whether the machines are okay, whether the method you're properly done, what is your input material, what is the process done, what is the resting point, these are all basic engineering. We have to, and then how is the material being handled? How is the measurements being done? How is the maintenance being done? If you just apply the 5M conditions of the basic manufacturing in a systematic way and ensure that it is captured, you as a leader of a company will know digitally on your cell phone or on your computer how the machine is running. Why are we doing this? Because in any areas, believe me, there is so much of waste happening. We have a lot of rework waste. You have a lot of, if you really see cost of, there are two types of quality level. Okay, if you extend the same thing forward. One is quality of good quality, cost of good quality. Cost of good quality is how we have done your design well, how we done capturing the inspection very well. This is all cost. Okay, it's involving the cost. But there's another thing which we are forgetting is cost of poor quality. Cost of poor quality is two things. Again, rework. Many of the things are scrap. Many things the rework is happening. That's a cost. Second thing is if you're going to the customer, the recall is a huge cost. That people are not capturing. If you really see the ASQ's trend today, I think yesterday it has come in papers, 75% of people don't capture cost of poor quality. If you are able to work towards cost of poor quality and improve upon it, that helps you being competitive. Cost comes down. Your own wastages comes down. So I'm just extending the same thing. I'm not, everything has a step to follow. I'm not saying everything is easy over the front. But if you understand the bigger picture why we are doing, go and apply in every element of work. Every MSMEs can lead the entire country because they are doing it for the entire world. So we have to change the mindset. That is the thinking differently is a theme which I'm trying to talk about. It's very, very important. So that is the area in which go step by step, apply those things, go into the basics, bring the sensors into low cost sensors are available, bring it into the area, get the machine talking to you, ensure that you're producing well, hence reduce the waste. So when you have rework being reduced, when there is a rejection getting reduced, are you not improving your cost? Definitely the cost comes down. Hence becomes competitive. No need for any person to say you have to reduce cost every 1 year, second year, third year. Work on the basic principles of your process itself. That's the approach we are trying to take. And I always talk about this in any of the supplier discussion, going to the place. Third thing, very, very important thing is going to the Gemba. Going to the
Yes.
place in which actually work is happening. Place in which whether they're seeing the drawing, whether the operator is seeing the drawing to do it, whether he's seeing the standard operating procedures, we have to become strong in that. There is no other rocket science. And there's no other way. If you have to follow the steps, you will succeed. And as a leader, put into digital way, get all data, take decision based on digital information with data. That becomes a change. I think
Thank you, sir.
huge opportunity, and that's why I said energy. That energy among all of our team should energize. I want to do well because there's an area I'm doing for the entire world. India is growing. I am a part of growth story. That's the way I like to look at it, and that's the way I think this. We are trying to push same way in BCIC whenever we talk. But I think it's important for us to take this approach in any area, and it is. It's not rocket science. It's a very, very basic way of doing it, but doing systematically.
Thank you so much, sir. Data-driven decision-making process. We need to follow the principle of basics of engineering, 5M conditions, and you rightly said that we need to measure the cost of poor quality. Thank you so much, sir. I come to Karthikeyan. We spoke about a digital twin just now. So the questions related to that only. We speak about simulation, right, Karthikeyan?
Yeah.
What role does simulation play in improving manufacturing quality, Karthikeyan?
Okay. Simulation is like a toy baby of a real baby. So what you try to experiment on real life, you can't do test hypothesis all the time on the real. So you need to have some tool where it helps you to play with your hypothesis, your ideas. It's like a sandbox, safe sandbox. I would put the word safe sandbox because the sandbox is that you can scrap it, you can rebuild the new sand idea. So simulation should be flexible and it should be able to model any new product or the process or any specific intended quality that the company would like to embark. So what happens is when the manufacturers can run what if scenarios by new routing, suppose he wants to, small shop, he wants to do a new rerouting or cycle time optimization he would like to do. Or if he wants to add some inspection points and tolerances measurement criteria. So this is primarily a tool without any risk. Virtual testing without risk is a simple word that simulation can help one. It also helps you to reduce defects and variability by modeling a full production line, and simulation helps to identify the bottlenecks, the overloads in the system, unusable steps, which is time wasting steps, what Devarajan talked about, Gemba, a lot of processes. How do I do when it is in the plant, but can I do it virtually and see if I can play with it to see some amount of hit and trial method I can eliminate and do it through the virtual world. We also call this design of experiments. A simulation helps you to do DOE studies. And you look at it, since you come from, I see you many times in ADAS. I see a lot of photographs and you drive ADAS cars and other things. The car, why I am coming to this, the products are becoming more and more smart. Smartness is created by embedding some knowledge into the material product, which is a software, which is an intelligence. How does this intelligence come? Basically by writing certain intelligent codes. Even writing the code, making the product smart is also should be a good quality code. It should have a latency in responding. It cannot After the collision happened, if my vehicle inspects me, yeah, you hit the thing, it doesn't help you. So how quickly I'm able to detect, I can send the instruction, I can make a corrective action. So it is no more product is only on the shop floor. I would say that the quality transcends to the smart products and smart sensors, smart diagnostic systems which can make informed decision. For this, you cannot really make many systems to run it into the field and try and come back. So it should be having a simulated system called model-based system engineering. MBSE is the one which you hear now many places. The system engineering aspect of it, where there is a good amount of software being also an integral part of the real metal. So the quality need to come not only from the physical finance scenario, even in abstract scenario like code, software codes, from that level also it needs to be imbibed. It is putting a lot of threat on many industries, because there are going to be more and more impact this will create, because the products and the technology need to be very, very robust enough in this field. So in nutshell, it should strengthen the control and traceability. It should also help on faster improvement. The simulation should help me to correct my processes and help me in realization. So I'm just summarizing, it is a safe sandbox. It helps you to do design of experiments. It helps you to create a good control, and it is able to model a real virtual twin where I am playing with it. So it's a toy in your hand.
Yes, thank you so much, Karthikeyan, giving me toys and to me and everyone. And you rightly say it's like a simulation is like a sandboxes. And you spoke about model-based system, which is very, very important. Thank you so much for your important. I come to Prakash sir. Before I have a question. Before that, I see a nice question in the chat box, and I will take up with Prakash sir and Doctor. Anyone can answer. So this is a question from Mr. Prakash Nayak from Tiny Prism Labs Private Limited. He says we build computer vision. We build computer vision based and IoT based solution for our customers. We often encounter challenges to integrate our solution to existing system or standards of the workflow and soft floor. What would be an efficient approach strategy to reduce integration challenges even after the solutions is ready? The solution is built, how the integration challenges strategy we should adopt. I'll ask this to Prakash sir, and then anyone can answer, sir.
Yeah, I think point well taken. I think Mr. Mahesh is actually referring from a condition or an environment where there are a lot of legacy or old systems are there. It could be old machines, it could be old controllers and the systems. And nowadays we actually have a clear interfaces available in terms of machines, whether you can easily integrate computer vision to the old systems. Integration solutions are available. Integrators are also available. And I'm very sure Karthikeyan also, who is also working with a lot of such, equipments and the instruments, will be able to do it. Exactly, I think the question is more on strategy to reduce integration challenges. See, I would put it like this. One is, of course, you need to have your people skills. That means you need to have a person who has a skill of the old systems, who knows about the old system and the new system. So which means you will have to invest on people, train people on those, to understand the new old systems as well as new system. Thereby, you can actually bring in what is called as an integrated one which integrates the old and new. So this is one aspect of it. And I'm very sure Mr. Karthikeyan would like to come in on in terms of the the other side of the digital side of it.
Actually, the technology connectors are the thread, digital thread, I would say. When there is an equipment capable of capturing, the thread could be the information or the data structure, or what is that information that you really synthesize from the sensor. Is it an image decoding, or is it about the temperature data, or is it a discrete data or a continuous data? What frequency it needs to be done? Then automatically the software which is receptive of this need to know at what frequency I need to do and what latency I need to do. It helps to know there, as Prakash said, as Devan said, there is a technology gap in every aspect because every customer want to be very different. They don't want to embrace commonly available. They think every process is mine is unique as compared to my next doorstep. So they want to be personalized and very specific about their own. Then there is a customization layer coming into picture. If it is a mass adoption, what is available in the market can be embraced. When I am very specific and very unique, we need to build a kind of a robust prototypes to see how does this system can handshake. But broadly, there is a framework that is available. There is no ambiguity about it. It is not something that the company is going to first time integrate. This process existed in the past. It will continue to exist now and future too. So it's only a question of time. What is the challenge, real challenge? Is it a cost? Is it a speed? Is it a capturing ability? What is, if you can go to the root cause, we can definitely recommend a right framework for this person.
Just adding to that point, recently also, we have also encountered this. In fact, not encountered, I would say, we have come across a solution already. See, nowadays, you're talking about computer vision based IoT solutions. Now, the technology has changed so much that you have a camera, an ordinary camera. On that, you have an AI algorithm built on it. Actually, you don't need to have any integration in a shop floor. In fact, we were already introduced with this kind of a solution where an ordinary camera with an AI algorithm built on it, and it can be so much fast integrated. Just an ordinary camera can do wonders for you. So I think probably the world is changing with the AI so much rapidly. AI itself is changing so rapidly. Now, digital technology has become a little old compared to the AI. I think Mr. Ravindra Saha is an expert in AI. He will be able to even give a better answer to this. So the AI is changing so fast that even these kind of challenges can be easily overcome, provided we know exactly what is the real issue. Yeah, Mr.
Thank you so much. Thank you so much. Very beautifully answered. So we have very limited time. So, sir, there is a fantastic question, Devarajan sir, for you. I see in the chat box. So I'll just take up with you. Ramdayal Guraj is asking, he's from food industry, Indo Nishan Foods Private Limited, instant noodle manufacturing company. His question is related to zero defect concept, sir. What strategy can we implement to implement the zero defect concept in food processing industry? As every product startup, we face lot of rejection and even in every changeover. So that's the question, sir. Sir, Dr.
Is it on the food industry? If I understand,
yes,
this is the food industry?
Yes.
Okay, sir. I think thanks for the good question. See, now zero defect, in fact, in food industry should be ultra zero defect. Because it is consumed by the people. So it's very, very important. Even a particular amount of stone or a particular amount of this thing cannot come into food industry. So more and more important, according to me, is to go into the elements of the work which you're trying to do. Because if you say, for example, you're trying to make a final material, you have to ensure that the raw material is okay. So a lot of vision systems are available to ensure that sort out any impurities coming at the raw material stage. So we have to go from the raw material stage of the component level and the process stage, temperature. If you're making that powder in a particular area, what temperature the baking is happening. So we have to go into the elements of work of the process to build the product. So food industry, I think, is a very, very important industry, including the way of handling. You can't have material handling open space, which ensure that your hair, everything is covered properly. You have to treat it because as if you are going to consume yourself as the food industry which you're trying to make. So by going into a bigger picture of the user as a customer, as the health of the person, as the life of the person, if we build the process, I think it will be a straight away going to the element of work, process, measuring the same area, temperature, putting all the information about the way of it's handled, how it is measured. Same principle applies whether the food industry or on the automobile industry. However, it's much more important because human is consuming it. So in that context, clean room area, clean room, it is required. See, what happens is we think that only by making the process proper, you have to build the environment around it properly. If there is a food industry, you should have a proper clean room. Ensure that no ingress comes from outside. So, and looking at every part of 5 a.m. conditions of every area has to be improved. Hence, the product of quality will be better, consistency will be better, and your volumes will pick up. So, build the process by the step by step of the elements. Ensure that you're trying to capture the elements for the consistency of it. Ensure that it is properly monitored for the cleanliness of entire area, the food industry, and you're able to achieve. So, and I'm telling you, this is not big rocket science at all. We have to ensure that you're going to monitor every area. And today, cost is definitely coming down in terms of the elements. However, as the volume increases, the cost per product also will come down and it will be more competitive. So please look at it as some area you have to invest, ensure that the process is made. Higher volumes, definitely the cost will come down. And second point is, again, variety will change. The food industry, a lot of variety will come. How flexible are we? How flexible are the equipments are? So a little bit more important is to be given in the design of the process itself on the flexibility, adaptability, environmental cleanliness, and the flow in which the process has to happen. You can't have storage kept over there and overnight I'll take it up. Everything has got a shelf life in terms of the elements of process inside the factory. The flow is very, very important in the food industry. So I think I'm just giving you an overall picture, but it is a very, very important industry. And if you are in the food industry, more and more important to apply digital flow manufacturing, go into the basic of it, and definitely you'll be able to achieve the results as what we can see. That's the way I look at it, Ravindra.
Thank you so
I
much,
hope I
sir.
have answered it, but I think there'll be more
Yes,
questions.
sir.
We can always take it up
Yes,
later.
so thank you.
If you're a
Thank
member
you,
of
sir.
BCIC, we can talk it over in BCIC.
Yes, he's acknowledged, Mr. Amdal acknowledged that he got the points from you, sir. So, sir, I have a questions before I take up other point. We have got still 15 minutes to go. I have a questions to Devarajan sir and for Prakash sir and everyone. When we look at the quality of manufacturing, the Japanese principle, they lot believe on visuals, visualization, and that's why the things happen. So when you talk about the quality, rework, rejections, all comes right. If you are able to measure it, convert that into the cost, then it impacts a lot. So my question is that do you suggest and how do you see that it is implemented in your experience and your industry that all this rework on live is measured, the quality rejection is live is measured, so much part is rejected, so much of effort, time, cost is wasted, and we convert that effort into the cost. And on the line side, at the soft floor level, the top level, if we display that key, we are losing money in the cost. So here, if technology that intervention comes and we see directly looking at the Japanese principle, then we act immediately. So anyone can share your insights, sir.
Okay, I think I will just come in. It's true that what you can measure and what you can actually visualize actually has an impact, no doubt on that. But I'll just, in the context of India, I'd like to just a little bit move away from the usual stuff, what we talk about, visualization and all that. See, Indians are generally moved by emotions. Okay, I think this is a fact. More than your placards and the visual boards and all that. So the leadership, the way the leadership actually communicates has an impact. Take for example, I just draw some parallels from our Prime Minister. The way actually he addresses and impacts the audience in terms of generating that kind of a passion to the made in India, make in India, Atmanirbharta, and zero defect, zero effect has a greater impact when it comes to changing the mindset. I agree with you from a perspective of actually later on, quantifying and then trying to minimize is, of course, the all well-known good practices of a Japanese manufacturing practices, the visualization tools definitely helps, no doubt about it. But if you start doing only with the visualization and quantifying, you won't find a better buy-in from the people. It takes a lot of time. So the starting point, the inertia needs to overcome, especially in the Indian context, and especially when we are looking at a bottom of the pyramid, because where the products are produced or where it actually happens at the Gemba, the people are not so much moved by any of our tools, what we talk about in the current context. They are moved more by emotions, the way we address them, the way we actually, appeal to them, trying to adopt these different practices. And this is, I think, experienced by all of us who actually work from top floor to shop floor. From, when in a company we have a doorman to chairman, if you want to really make this change happen, the doorman should feel what it means, is what is actually a quality,
True. Absolutely right.
So this is possible
Okay.
only, especially in Indian context, I would say. And the greatest example is our own Prime Minister, how he is able to, move the entire nation with a lot of such new initiatives, which I'm not saying only about quality, I'm just talking about in general. So these are
Absolutely
some
right.
of the thought process from
Certainly.
myself.
Anything, Karthik?
One point I think very important. I think Prakash did mention. See, according to what's happening around, we are all working for the customer. All of us are working towards an external customer who pays
Internal
for the
customer
product,
also.
and hence the product comes. There is an internal customer which we forget.
Yes.
Suppose the operator is an internal customer. We as engineers, do we make processes which is easy for the operator to do? Do we design a processes which is consistent for him to make? So it starts with us in terms of engineering for a customer. So we should know who is the customer. So according to me, our internal customer who makes day in and day out in the shop floor, who develops the product, maintains it, ensure that there's no problem in the product which goes out of, is a main customer for us. So if we change that mindset, that operator is the main customer. Second thing is we should walk the talk. Whether it's 5 years or talk, not only talk. If suppose you go into a shop floor and we find that a small problem in the machine, are we enabling him to solve the problem? If there is a small paper on the floor, are we picking it up ourselves and throwing it in a dustbin, or are we calling a person to clean the area? So I'm just looking at the way of mindset, the way of culture starts with us in many of the areas. In fact, in our company, we take it even to the home. Many of the operators inside our factory who makes that disciplined way of this thing takes it to the home. We have home kaizens. They do improvement in their home, saying that this is the way the entire thing is kept. He can't take the key of the scooter if he doesn't take the helmet along with it. So I'm just looking at it. It can be applied to the operator in the person, to the shop, to the family, and it extends through. So I think this drive happening, and definitely Prime Minister, which I think the way he talks, the way the amount of meeting people, understanding what he talks to the customer who prepares for it, whether it's a cricket team or a women's cricket team or an Indian cricket team coming to pitch or a space program. I think we should know a subject what we should walk the talk. So I think many of the areas, I think this program today is to ensure that we are all leaders in our own area. We should take it upon our own onus to think quality differently, and quality is a way of life in which we are talking about. That's the area in which it's an important thing for us to say that we will drive consistency, we will drive reliability, we will drive the consistency of the operator who is doing with us. We are going to support them, enabling them to make. We ourselves will deliver the outcome. So if you really see, quality is not an outcome. Okay, systems are the outcome. Walking the talk is an outcome. Quality is enabler to ensure it is done consistently, according to me. That it's an intrinsic way of looking at it. So most important thing is how we drive this, and that will make the difference And that is the way in which quality think differently is the right approach. We are having a good process. Your MSME is doing well in our own area, but it is not enough. Can we go to the next level? Can we go to the next level of our areas? That's the change thought, which will help ourselves to grow, because MSME is most important for OEMs. We like OEMs, all the MSMEs to grow, all the education institutions to grow, because these are input for the industry. And hence we can take it for the India's growth.
Thank you so much, sir. Very nice input. So we have got internal as well as external customer both, and walk the talk, which we talk about Gemba. So I see there are many questions in chat box. Because of limitation of time, we have got 7 minutes to go. So I will request each of the panel member to share his comments, the last comment from this session. I'll start with Mr. Karthikeyan.
Okay, I think it was well discussed and deliberated based on diverse industries and the need. One of the factors that we touched upon was there should be a kind of digital thread connecting from all processes, which will help many islands within the factories or the processes do not have a gap. There is a kind of a weak link, which is creating a lot of assumptions and things like that. So it is fundamentally important. There should be a good architecture, robust architecture in the company, a DNA for the manufacturing, which also creates a kind of a threat continuity to ensure that all processes can be controlled, measured, controlled, and acted upon for an effective customer value.
Thank you so much, Karthik. And Prakash, sir.
Yeah, so maybe I will take about 3 minutes. I wanted to share something to all the audience, which is very useful, because in these sessions we talked about think differently. It should be looked from a systemic point of view. And like I think Dr. Devarajan rightly mentioned, quality is the end result. We have also talked about digital twin, industrial 4.0, and a lot of cross-functional collaboration is required actually to achieve. Now, I would like to share to the audience one of the very interesting video, which is about 2 to 3 minutes. Very interesting. It will open our eyes about when we talk about, when you say what is systems thinking. This is from a Dr. Ekhoff, who is a well-known in the field of systems thinking. I just wanted to share, I think, let me know whether you can see the screen.
It's coming. I can see now. We can see now. It's an email, huh? Okay.
Just check. You're able to see my screen?
We can see your screen.
Yes.
No audio. Can you just share audio also?
Share audio also, please. Audio is not coming.
Audio is not coming?
No, not coming.
Share with audio.
Include sound, okay.
A system as a whole,
is that okay?
Spelled with a W.
Yes, we can hear.
That consists of parts, each of which can affect its behavior or its properties. You, for example, are a biological system called an organism, and you consist of parts, your heart, your lungs, your stomach, pancreas, and so on, each of which can affect your behavior or your properties. The second requirement is that each part of the system, when it affects the system, is dependent for its effect on some other part. In other words, the parts are interdependent. No part of a system or collection of parts of a system has an independent effect on it. Therefore, the way the heart affects you depends on what the lungs are doing and the brain is doing. The parts are all interconnected. And therefore, a system is a whole that cannot be divided into independent parts. Now, that has some very, very important implications that are generally overlooked. First, the essential or defining properties of any system are properties of the whole which none of its parts have. For example, a very elementary system you are familiar with is an automobile. The essential property of an automobile is it can carry you from one place to another. No part of an automobile can do that. The wheel can't, the axle can't, the seat can't, the motor can't. The motor can't even carry itself from one place to another. But the automobile can. You have certain characteristics, the most important of which is life. None of your parts live. You have life. You can write. Your hand can't write. That's easy to demonstrate. Cut it off and put it on the table and watch what it does. Nothing. You can see. Your eye can't see. You can think. Your brain can't think. And therefore, when a system is taken apart, it loses its essential properties. If I bring an automobile into this room and disassemble it, although every single part's in this room, I don't have an automobile. Because the system is not the sum of the behavior of its parts, it's the product of their interactions. Now, what does that mean? If we have a system of improvement that's directed at improving the parts taken separately, you can be absolutely sure that the performance of the whole will not be improved. And that can be rigorously proven. But most applications of improvement programs are directed at improving the parts taken separately, not the whole. Basic principle. An improvement program must be directed at what you want, not at what you don't want. Systems principle that is ignored in most of the practices is that they practice in a way which derives from the work of Walter Shewhart at Bell Telephone Laboratories in the 1930s. Shewhart developed statistical techniques for determining defects. A defect is something that's wrong. Now, this should be perfectly obvious. When you get rid of something that you don't want, you don't necessarily get what you do want. And so finding deficiencies and getting rid of them is not a way of improving performance of a system. And determining what you want requires your redesigning the system, not for the future, but right now, and asking yourself, what would you do right now if you could do whatever you wanted to? Because if you don't know what you would do if you could do whatever you wanted to, how in the world can you know what you can do under constraints? But people don't ask themselves that question. Continuous improvement isn't nearly as important as discontinuous improvement. Creativity is a discontinuity. A creative act breaks with the chain that has come before it. It's not continuous. One never becomes a leader by continuously improving. That's imitation of the leader. You never overcome a leader by imitating them and improving slightly. You only become a leader by leapfrogging those who are ahead of you. And that comes about through creativity.
Thank you so much. Beautifully 5 principles.
Very valid. This thing is very good. See, I was just thinking the similar way what you had brought. Okay, I was thinking we're talking about data today, capturing data and all is very important. No, it should be reliable data. It should be right data. So it's important that we capture data integrity first in all our areas. I think very important thing which I mentioned, that we can't keep on improving every element of it. How we can work on integration of it. Very good video. Thanks, Prakash. I think it's very interesting and thought-provoking too.
Thank you so much. I think time is also up. A very beautiful insight.
Sorry, I think I just got messed up with the audio. I mean, I just wanted to convey that. I think Dr. Devarajan was mentioning about it. I could not hear much. And I think that's what I could say that, when we talk about so many tools, quality and all that, we have to rightly mention by all of you that we must look at system. I think that was very well conveyed by Dr. Ekov. I'm very sure, I think every audience would have got the message from that, and definitely they'll use that.
Thank you so much, Devarajan sir, Prakash sir, and Karthikeyan. Very insightful and lovely, good questions came up. Thanks to all participants. I'd now like to over to Rupa ma'am. Are you there, Rupa ma'am?
Thank you,
sir.
Rabindra-san, also for your wonderful questions, and I think it has definitely given a lot of
Thank you,
Thank you.
Rabindra.
food
Thank
for
you.
Thank
thought
you.
for
Thank you to everyone. Thank you.
Rupa,
Thank you
over
very
to
much,
Good
sir,
evening.
to all the panelists for this very wonderful and for providing insights into the subject, sir. Thanks once again on behalf of the chamber, and thanks to all the participants for joining the session. Thank you.
One more point to the participants. I think whatever good points you have raised, if you have any other doubt, you can write to BCIC. Secondly, we have many programs like this in BCIC. Every alternate day there's a program. And if any one of them are not member of BCIC, please contact Rupa at rupa@bcic.in to become member. And you'll have so many programs, so many interactions with us. And we are in the 50th year, and then there'll be so many programs coming forward in this year. So good opportunity for all of us to be a part of this, because BCIC will take, we always say Namma Karnataka, gateway for future India. We want to take Karnataka in a big way, apart from many other things. But I think all of you should come member, and all of your inputs also will help us to make this program better. Thank you, Rupa.
Thank you.
Thank you
Thank
so
you very
much.
much. And
Thank you.
Madam Haruki-san is there, sir, from Osaka. She has joined from Osaka. Madam, do you have
Thank
any
you.
feedback on the session or any queries, ma'am?
I think
Haruki-san,
she may be
Arigato
muted.
gozaimasu.
Check.
Hey,
She
she's
may be
come.
muted, I think.
Thank you.
No, no,
Thank you,
she
sir.
is all-
Thank you.
Thank you. Bye-bye, everyone.
Thank you all.
Thank you very
Bye.
much.
Bye bye.
Bye-bye.
Bye-bye.